Hello students, so we're going to go ahead and begin chapter 11 on flow rates and dosage rates for intravenous medications. So we'll do a brief overview of the chapter and then we'll do some examples. So I encourage you to consider doing the practice problems at the end of the chapter before attempting the homework, and you can find them on pages 327 to 328 in the hard copy of the book, and then the answers to the practice exercises are in the back. Okay, so in the ebook, the practice exercises start on page 328, and they come right before the regular exercises in the chapter. Okay, so in this chapter, we will discuss how to calculate the dose rate, which is the rate at which a patient receives a drug in an IV piggyback, or IV push. Okay, we will also convert from an IV dosage rate to a flow rate in milliliters per hour or drops per minute. Likewise, we will convert a given flow rate to a dosage rate. And lastly, we will discuss compound rates, okay, where a drug order is based on a patient's size and the amount of time. Okay, you can see more information about compound rates on pages 316 to 318 in the hard copy of the book. So if we go to page 316 in the ebook, okay, compound rates are discussed starting on page 317. Okay, so before we begin, let's go to the beginning of the chapter. Okay, which starts on page 304. Okay, and it gives you a list of topics that are covered in this section. Okay, so due to the time constraints and the time we have left in the course, we won't be able to cover all of these topics, but we'll cover the majority of the topics, okay, that I've already listed. And then I may create additional videos for additional topics as necessary. Okay, so let's go ahead and go to the next page. Okay, and the title here is Intravenous Administration of Medication. So intravenous IV administration of medications provides rapid access to a patient's circulatory system, thereby presenting potential hazards. Okay, so errors in medication dose or dosage strength can prove fatal, so therefore caution must be taken in the calculation, preparation, and administration of IV medications. Okay, so typically a primary IV line provides continuous fluid to the patient, and then secondary lines can be attached to the primary line at injection ports, and these lines are often used to deliver continuous or intermittent medication intravenously. So a secondary line is referred to as a piggyback or intravenous piggyback, or IVPB for short. So with intermittent IV infusions, the bags generally hold 50 to 250 milliliters of fluid containing the dissolved medication, and usually require 20 to 60 minutes to infuse. Okay. Okay, so in other words, IV piggybacks or IVPs provide additional medication, okay, and are attached to an existing IV line. Okay, and you can see a picture on the next page. And then it talks about HEP locks and saline locks. Okay, so I'm going to go ahead and skip over that. So an IV push, or IVP, or bolus, is a direct injection of medication and direct injection of medication either into the HEP lock or saline lock, or it goes directly into the vein. Okay, so that's another type of IV medication administration, is an IV push, or IVP. Okay, then it talks about a volume control set, also called a burette. That is also connected to an IV line. Okay, and burettes are often used in pediatric or geriatric care, right, where accurate volume control is critical. All right, and we discuss the use of burettes in chapter 12 when we discuss pediatric drug calculations. Okay, so the next page talks about intravenous piggyback infusion, so I encourage you to read this on your own. Okay, but here's what this might look like. So you have a primary infusion. Okay, that's in this bag, and this is the primary IV line, which is here. And then you have another infusion taking place called a secondary infusion. So this is what's called a piggyback. Okay. And what happens is that it's a smaller volume than the primary infusion, and it includes additional medication. Okay, and it talks about how if you do an IV piggyback, right, the primary infusion does not start until the secondary infusion is finished. So once the secondary infusion is finished, right, then the primary infusion can start. Okay, so this is an example of an IV piggyback. Okay, so before we go any further, we want to make a note of these two formulas, because you're going to be using these two formulas throughout the chapter. Okay, so the first formula is the formula for flow rate, which we saw in chapter 10. So remember, the flow rate of an IV is equal to the volume of fluid, okay, divided by the time. Okay, then we have something called the dose rate. Okay, so since the patient is receiving an IV, okay, so if it's an IV piggyback or an IV push, right? There's a drug dissolved in the IV fluid. Okay, so as the IV is flowing into the patient's body, okay, the patient is also receiving the drug. Okay, so the rate at which the patient receives the drug is called the dose rate. Okay, it's equal to the amount of drug divided by the time. And then lastly, you've actually seen this formula back in chapter 6, where we discuss dosages that are based on a patient's size. Okay, either by their weight or by their body surface area. Okay, so remember, we take the size of the patient, either their weight or body surface area, and then multiply it by the order. Okay, and then that gives us the amount of the dose. So the first type of problem that we're going to discuss is converting from a drug rate to a flow rate, and vice versa. Okay, so what I mean by vice versa is that we're going to go backwards as well, so we're going to convert from a flow rate to a drug rate. And then we'll also talk about examples where you're asked to find the drug rate by itself, and the flow rate by itself for an IV. Okay, so in our first example, we have an IV piggyback that is infusing at a rate of 0.5 micrograms per minute. Okay, so again, this is a rate. In fact, this is a drug rate, because remember, flow rates are usually given in drops per minute or milliliters per hour. Okay, so we know that this represents a drug rate. Okay, so the solution concentration is 50 micrograms and 100 milliliters of normal saline. Okay, and the question is, what is the pump setting in milliliters per hour? Okay, so we're going to go from the given drug rate of 0.5 micrograms a minute to the pump setting of the IV in milliliters per hour. All right, so in other words, 0.5 micrograms a minute is equal to how many milliliters per hour? All right, so that's what we're going to start with, the drug rate in micrograms a minute. Okay, and the only other piece of information that we're given in the problem is the concentration of the drug in the IV bag, which says it's 50 micrograms and 100 milliliters of normal saline. Okay, so because we want our final answer to have milliliters on top, okay, what we're going to do then is multiply by the following fraction. Okay, so we're going to multiply by 100 milliliters over 50 micrograms. Okay, so we're going to flip over the fraction representing the concentration, okay, which is given in micrograms and 100 milliliters. Okay, flip it over, multiply it by the drug rate, so that in the process we eliminate the units of micrograms. All right, and you can simplify that fraction if you'd like, but we don't have to. So we're going to take 0.5, multiply it by 100, and then divide by 50. So 0.5 multiplied by 100, and then divide that by 50. Okay, we get 1, right? So this is equal to 1. So what are the units now, right? So in the numerator, the units are in milliliters. Okay, and in the denominator, we have units of minutes. So 1 milliliter a minute is the flow rate, but we want the flow rate in milliliters per hour. Okay, so we want to go from milliliters per minute to milliliters per hour. Okay, so we know that 60 minutes is equal to 1 hour, so we're going to have 60 minutes in that numerator of the next fraction. So we're going to multiply by 60 minutes, okay, over 1 hour to get the desired units of our final answer of milliliters per hour. Okay, so in the process, we eliminate the units of minutes. Okay, so we're taking 1 and multiplying by 60, essentially. Okay, so the pump setting of the IV is going to be, so 1 times 60, easy enough to do in your head. Okay, but in any case, right, 1 times 60 is equal to 60 milliliters per hour. Okay, so that's the pump setting, or the flow rate of the IV, so 60 milliliters per hour. So in other words, in order for the patient to receive the drug at half a microgram a minute, okay, the pump setting must be set to 60 milliliters per hour. Okay, let's look at the next example, and it says that we have an IV Piggyback infusing at 120 milliliters per hour. And it says the concentration is 50 milligrams and 100 milliliters of normal saline. Okay, so what is the dosage rate in milligrams a minute? Okay, so the problem is asking us to go from the flow rate of 120 milliliters per hour, right, to a corresponding drug rate in milligrams per minute. Okay, so we're going to start with the 120 milliliters per hour. And the piece of information that'll be relevant to help us get the answer is that the concentration is 50 milligrams and 100 milliliters. Okay, so we're going to multiply by that exact fraction, so we don't need to flip it over. Okay, so we're going to multiply by 50 milligrams over, okay, 100 milliliters, and you can see that the units of milliliters are eliminated in the process, and then we're left with the units of milligrams in the numerator and then hours in the denominator. Okay, and once again, you can simplify the fraction if you'd like, but I'm going to leave it as is. So we're going to do 120 times 50, and then divide that by 100. Okay, and we end up with 60. So that's equal to 60 milligrams per hour. Okay, so that's the drug rate in milligrams per hour, but we want the drug rate in milligrams per minute. Okay, so we're going to multiply by another fraction, right, to eliminate the units of hours in that denominator. Okay, so I must have the units of hours in the numerator of the other fraction. Okay, the fraction I'm typing in. All right, and then the units of minutes in the denominator of that same fraction. Okay, so we're basically going to divide that by 60. All right, and we're going to eliminate the units of hours in the numerator here of the second fraction and in the numerator, or rather in the denominator of the fraction that comes before it. Okay, so 60 divided by 60. Okay, that should seem pretty obvious. All right, 60 divided by 60 is equal to 1. Okay, so the drug rate, so the patient is receiving the drug at a rate of 1 milligram a minute. Okay, so if the pump setting is at 120 milliliters per hour, okay, that means the patient is receiving 1 milligram a minute of the drug.